Hello, welcome to our webinar on pipe flow measurement with a transit time flow meter. This webinar is brought to you by Electronic Data Solutions. Transit time is also known as time of flight technology, where sound pulses are transmitted upstream and downstream between two elements mounted on the outside of the pipe. The two elements, or transducers, alternate function between send and receive. However, the speed of sound of the pipe material as well as the liquid must be measured to compensate for the changes in angle that occur as a result of the acoustic interface between the pipe wall and the fluid. Typical transit time applications where you'll have the best success include treated water, gray water, irrigation water, ultra-pure water, coal bed methane release water, desalination water, and raw sewage. Transit time flow meters are used on liquids that do not have large amounts of suspended solids or aeration. You'll want to avoid using transit time technology on any of the following: sludges, slurries, emulsions, dry concrete pipes, non-full pipes, and multi-state fluids. Some of the features of the transit time technology that we'll be discussing today are a very good accuracy of plus or minus 1% of the reading, which can be better in many cases. Transit time flow meters can measure bidirectional flow up to 40 feet per second using clamp-on non-invasive transducers that could be attached to pipe sizes ranging from 1/2 inch and greater. The question is often posed, what's the maximum size of pipe that I can use these transducers on? And there isn't a hard fixed answer to this because there's a lot of variables, number one being the pipe material and the second one being the pipe wall thickness and the liquid in there. Generally, we like to go no larger than 55 to 60 inches pipe. The meter has a positive, negative, or net totalizer function, so if you do get bidirectional flows and just want the net positive flows, you can certainly set it for that. The UTM10 transit time flow meter has a USB interface to a PC. We'll talk about that a little bit later in more detail, but this software allows you to do all the setup through one easy interface, or you can also use the 4-button keypad and LCD display. The LCD is backlit, so if you're working in low lighting conditions, it's very easy to see the screen. It has a very easy wiring interface that we'll show in just a few seconds. There's advanced communication options, including digital and analog inputs and outputs. The housing is an aluminum enclosure that's rated for NEMA 4 IP65, and it's rated for Class 1 Div 2 for hazardous location installations. The UTM10 flow meter is compact, and as we mentioned, can be installed on pipes 1/2 inch and larger. It can display over 700 combinations of volume, rates, and totals. You can get transducer cable lengths up to 990 feet with no sacrifice in accuracy and signal integrity. So what this is basically getting at is you can have up to 990 feet separation between the sensors and the meter. This is sometimes very common if people want to install the transducers below ground in a vault, yet have the meter / display in a location, which makes it easy to see for personnel. The unit has a lot of standard outputs and communications, including 4 to 20 milliamp, RS-485 Modbus RTU communications, a frequency output, which is a rate pulse open collector, and then 2 open collector alarm outputs. Optionally, there's also an Ethernet card that can be installed inside of this. This uses a Modbus TCP IP or Ethernet IP and BACnet IP. As you can see, the UTM10 meter / display is very compact, 6 inches total width. It comes with a mounting bracket on the back of it that allows you to mount it directly to a vertical or horizontal pipe, or you can remove two screws that hold the pipe bracket on there, which just gives you a flat mounting bracket with 6.5-inch pre-drilled centers that allow you to mount it directly to a wall or to an enclosure. This is what the inside of the UTM10 flow meter looks at. So it has a hinged lid that you can raise up, and that exposes some terminal posts where you can wire your sensor. The sensors come detached from the meter with bare wire leads, so you can thread the sensor cable through conduit and then route it into the meter and attach it to the terminal post. There's 3 threaded openings in the bottom of the UTM10 meter that come pre-plugged. You can twist these plugs out and have your power supply go in one, your outputs out of another, and then your sensors into yet another. The sensor cables, if you don't want to route them through conduit and are just burying the sensors and want to save some time, you can also order the sensor cables with a rugged conduit, a rugged waterproof conduit around the sensor cables already, so when you can get those, you can just dig a trench, lay the sensor cable with the conduit in there, and then route it up inside of your enclosure. There's a number of communication options for the UTM10, so if you're using this in a municipal or industrial environment and you want to link a lot of those together, you can do so using the RS-485 Modbus RTU protocol, or again by purchasing the optional Ethernet modem and putting inside of that, which allows you to yet link more of these together and then route those back through a local area network directly to your computer. There are a number of sensor sizes and options available with the UTM10 meter that again allow you to work in pipe sizes from 1/2 inch on up. I mentioned the flexible armored conduit option. There's also an IP68 NEMA 6 rated for submersion sensor and sensor cable combination. The most common sensor models that we sell are the UTT050S, which works in pipes from 2 inches to 24 inches diameter, and then for pipes 24 inches in diameter and larger, there's the UTTL, which is a 500 kilohertz frequency, where the UTT050S, which works from 2 to 24 inches, is a 1 kilohertz frequency sensor. We'll now discuss the installation considerations of the UTM10 flow meter. Some of the things that you're going to be prompted for, either through the software or through the keypad interface, or the liquid type, the pipe outside diameter, the schedule, class, and the material, the liner, if applicable. You'll need to know the type and the thickness, and then account for straight run pipe lengths, we'll get into in just a few seconds, as well as the flow range, min, max, and nominal. Places where you have the best success for a UTM10 installation are determined by the pipe material. Performance of the flow meter can be affected by the pipe material. Those that conduct ultrasound more effectively produce better signal strength and are in order stainless steel, plastic, copper. Up in the plastic, that includes PVC, HDPE, carbon steel is good, galvanized pipe is good. What you don't want to install it to, or the worst potential for success, are plastic and rubber lined pipes, and of course concrete pipes are not good, as well as corrugated metal pipes. Sensor location is one of the most important criteria for getting accurate flows. So you want to select a position on the pipe that will permit optimum flow meter performance. We typically recommend several pipe diameters of unobstructed straight pipe both before and after the installation area, and offer this diagram, which I've just taken out of the UTM10 manual, that will basically show you what we recommend for straight pipe run lengths based on the orientation of the pipe, such as a bend and out of plane bend, pumps, valves, transitions from other pipe diameters, etc. You want to select a position on the pipe that will be entirely filled with liquid when measurements are to be made. As such, you'll want to avoid downward flowing pipes that don't have a sufficient back pressure to ensure that cavitation is not present, and you'll want to avoid horizontal pipes that spill into open basins or flow downward via gravity. Now, if you have a horizontal pipe that spills into an open basin, you'll need to make sure that you've moved that sensor back far enough onto the pipe that that pipe is always running full pipe. If you don't have the proper straight runs of pipe, you'll need to sacrifice accuracy, and of course empty pipes will cause a loss of signal strength, and partially filled pipes will cause erroneous readings. This diagram shows the correct and incorrect place to mount the meter. Of course, we always want to make sure that we're upstream from valves, because they can cause turbulence and aeration inside of the line. There are a number of modes for mounting the transducers to the pipes. One of the common things before we get into the different modes shown is to always make sure that you mount the transducers off on the side of the pipe between, say, 1 o'clock and 1 o'clock and 5 o'clock, or 7 o'clock and 11 o'clock. You never want to be at the 12 o'clock or the 6 o'clock position. Avoid the 12 o'clock because a lot of times there's gases or aeration trapped in the very top of the pipe, and in a lot of pipes there's sediment at the bottom of the pipe. Now, depending on the pipe diameter, the software or the UTM10 meter display will prompt you to install the transducers either in a W mode, a V mode, or a Z mode configuration. The W mode is typically on smaller diameter pipes, so you get basically 3 reflections through the pipe before the signal is received at the other transducer. In a little bit larger pipes, you can use a V mode, where there's just 1 signal reflection off the wall of the pipe before it hits the receiving transducer. And in very large diameter pipes, we use a Z mode configuration, where the sensors are on opposite sides of the pipe. The sensors have alignment marks on those. One of the things that you'll be prompted for in the setup is it'll recommend a distance or spacing between the 2 transducers. So you can run a tape between those, and one of the first things that we recommend is that either watching the display or the software have it set in signal strength mode. And you can see as you're installing the transducers and as you move those around, you can see if that signal strength is increasing or decreasing, and you can strive for the maximum signal strength. For smaller diameter pipes, we have a track or a mounting bracket so that you can easily mount the sensors in the track or the bracket, get them spaced at the recommended distance, and then just simply band or mount that bracket to the pipe, which ensures the transducers are specifically lined up. This is an option. I say most people don't buy it, but I just want you to make you aware that it is available. Signal strength, as I mentioned, is one of the primary things that we're looking for, and to get a good signal strength you want to assure good mounting location. So the 2 conditions that we recommend are always horizontal before vertical or vertical after horizontal. This is a screenshot of the free software utility that you can get with the UTM10 flow meter. This allows you with a USB cable to connect your computer to the flow meter and do all of your setup on some intuitive, easy screens. Another nice feature of this software is that if you're setting up multiple UTM10 flow meters and they're all the same pipe diameter, just different locations, you can basically save this as a file or as a template, if you will, And then when you get to those new locations, instead of working through this information again, you just simply download or configure that meter using that saved file or template. If you're using the 4 keypad display, the 4 keypad and the LCD display to set up your UTM10 meter, you have a menu flow chart that you can basically, using the up and down arrow key and the enter key, transition between menus and make selections for things like pipe material, water type, liquid type, and things like this. So it's very intuitive. It's just a matter of scrolling through the menus, and again, this is why some people just prefer to use the USP software. The UTM10 flow meter is very small and can be used for portable or spot checking of pipes. So if you want to validate or verify flows from another flow meter, or to make flow measurements on pipes where there is no meter, a very portable system where you can just pack it in a toolbox or a Rubbermaid tote, move it around with you, strap the sensors to the pipe, plug it into a wall or into an inverter, or you may just want to have a small rechargeable battery in your tote with you that can be used to power the meter. A lot of people, when they're making flow measurements on larger pipes, as shown in this meter, will just use some ratcheting tie-down straps to hold the sensors in place. The system is also good for permanent locations. This is a very well done irrigation application. The large picture on the left shows the sensors attached to the pipe in a correct side orientation. You can see that the sensor cable is routed up through some conduit where it goes up on the surface and terminates into a weatherproof enclosure that houses the 12-volt DC battery, a regulator, and then the UTM10 flow meter is mounted to the back plate of the enclosure. And you can see the whole system is powered by a solar panel maintaining the charge on the battery. So this is kind of typical for our agriculture and irrigation customers that don't have AC power at their sites. The meter can also be housed with a RTU or a PLC and a SCADA system. So here you can see in a enclosure where they have AC power and a SCADA system, and then the small size of the UTM10 flow meter makes a very convenient interface to the SCADA system. That kind of wraps up our UTM10 flow meter introduction today. I do want to introduce you to Electronic Data Solutions. We're headquartered in South Central Idaho with 5 field offices in the western United States. We've been in business since 1986, so it looks like I need to update my screen there for years in business. We offer a wide variety of hardware and software for field measurement and data collection. I also want to let you know about our other instrumentation in our water resources business unit. We provide water level sensors and water quality sensors from some of the industry's leading manufacturers. We provide acoustic Doppler current flow meters for canal, stream, and river measurement, provide tools for hydrologists from Hydrological Services of America. We also provide other pipe flow meters from EMCO, who brings us the UTM10 flow meter. We have mag meters as well as vortex shedding flow meters, and then we also provide telemetry systems and data logging units. I also want to introduce you to our GPS and GIS business unit. We are a certified trainer and repair center for Trimble Navigation, serving the mapping and GIS industry. We're an Esri business partner and developer, and we also provide laser range finders, GPS-ready digital cameras, and rugged field tablets and computers from Mobile Demand and Juniper Systems. We also provide rentals, service, and support services. We have 5 full-time resources available for this, and equipment rentals out of our South Central Idaho location. Well, that's everything for today. I'd like to thank you for attending this recorded webinar on pipe flow measurement with a strap-on transit time flow meter. If you have questions, if you need additional information, Here's my contact information below. If you would like to test out a flow meter because you're not sure if your application is a good fit, we can also arrange for that, as we have some meters available that can be shipped out to you, or one of the representatives of our company can come out and show you this meter. Thank you very much, and we hope to have you attend some additional webinars from Electronic Data Solutions in the future.